So the next linked list question is linked list cycle. So what we're asked to do is check if there is a cycle in a given linked list. The way we define a cycle is at a certain point we have the next of a certain node equal to a node that we have already visited. So one way of doing this, the more intuitive way, is just by adding a visited set, right, of visited nodes, and we will do a current equals head to iterate through our linked list. So we do while current, so it's not none, we do current equals to current dot next, right? That's how we iterate. If current in visited, return true. So we have a cycle, right? If we reach a certain node that have already been visited, else we just add visited dot add current. We add our current node into the set of visited nodes. So this should work. This is one way of doing this. Not the other way. I mean, even though this is a easy question, but it is a bit harder to think of the other solution. I mean, without seeing this solution somewhere. So it's Floyd's method in determining if there is a cycle or not. So what we'll do is we will define two pointers. One that for each iteration will go two steps, while the other will go only one step. So we have a pointer slow and the pointer fast. And if at a certain iteration of our loop we got the we got the slow equals to fast, if they both contain the same node, we can say that we've got a cycle because we went through our linked list, and at a certain point we have both pointers pointing at the same node. So we do slow equals fast equals head, right? While fast dot next and fast dot next dot next. So there is one edge case that I should think of, which is if, for example, fast. If not fast, return false, because there is a possibility that we will be given a head that is actually an empty linked list, so there will be no values. So if we reach fast.next non-type of next of a non-type, it's an error. So avoid this. We can do to make it more comprehensible. We could do if not fast or not slow, but it's not really necessary because they both have the same value, which is head. So you would think that usually we start with the stopping condition, which is if fast equals slow, return true. But at the first step of our loop, we have both fast and slow have head, so this will always be true. So what we should actually do is we should iterate fast equals fast dot next, and I'll put the slow first, so it's better. Slow equals slow dot next. Turn false. So what's going on is we defined two pointers, slow and fast. Sometimes you will see some corrections where they use rabbit for fast and turtle for slow, but it's the same idea. So if not fast or not slow, not really necessary this part, return false. Empty linked list, then there is no cycle. While fast that next and fast that next, because it is possible that we reach at fast.next, we reach the end, so this is going to be none, right? And we cannot call next on a non-type, so we should check both, right? And we check this one first, obviously, and we'll iterate because at the first iteration we've got both slow and fast have the same value, which is head, or the same reference head, and this is the stopping condition if, and this should work. So submit. In the previous answer, where I used a set, we could have used, for example, the values, but I think case 4, no, it's case 5. You got the same values. So you got minus 21, for example. So it will not work because as each newly visited node, we put all the objects or our the whole list node with the value and the reference to the next node inside our set, which will use more memory. But if we knew we would never visit the same value, there is no multiple nodes with the same value. We could just save the value in the set and check if the value has already been visited or not.